Hello everybody. When we're talking about linear and nonlinear functions, it's pretty easy when you have a graph to look at. For example, down here, number 7 and 8, if it's a line, it's linear. If it's not a line, it's not linear. So those ones are fairly easy. But when you're given a table like this, you need to find the change in the y over the change in the x. That's the slope of the line. If that fraction is the same, if it's constant all the way down, then it's linear. So the way you do that is you find the change in the y. So from 25 to 20, you would subtract 5. From 20 to 15, you would subtract 5. From 15 to 10, subtract 5. And over here, from 0 to 7, you would add 7. 7 to 14, excuse me, you would add 7. From 14 to 21, you would add 7. And you can see if I take that change in the y over the change in the x, see right here, change in the y over the change in the x, I'm going to get negative 5 over 7 every single time. See, I'll get it when I do this one, when I do this one, it won't matter. I will get negative 5 over 7 every time. And because of that, this table is representing a linear function. If it's the same ratio, same slope all the way down, it's linear. Okay, so let's look at another one. Let's look at number 4. Okay, so the change in the y, I'm going up by 1. From 2 to 6, I'm going up by 4. From 6 to 24, I'm going up by 18. And it's okay if those numbers are different, as long as the change in x is also going to give you a ratio of that is constant, then that's okay. So from 1 to 2, it's up plus 1. From 2 to 3, plus 1. 3 to 4, plus 1. So if I make these ratios 1 over 1, 1 over 1, the next one would be 4 over 1. See, and I can already tell 1 over 1 does not equal 4 over 1. Okay, so because those ratios are not the same, this one is non-linear. So if you can get the same ratio all the way down, it is linear, and if not, it's non-linear. So let's look at number 5. Okay, so from 21 to 15, we're subtracting 6. From 15 to 10, we're subtracting 5. From 10 to 6, we're subtracting 4. And then here, from 6 to 5, we're subtracting 1. From 5 to 4, we're subtracting 1. From 4 to 3, we're subtracting 1. So if I make these, you know what, I'm going to color code them. This one would be negative 6 over 1. Negative 6 divided by negative 1 is positive 6. So the slope right there is 6. Now let me change the color. Now the slope right here, negative 5 over negative 1, that's negative 5. That's not the same as negative 6. And then here we have negative 4 over negative 1. That's going to give us a positive 4. So what's happening in this graph is it has a slope of 6, and then all of a sudden it has a slope of 5, and then a slope of 4. And you can kind of see that once you change the slope, it's going to make the line non-linear. The slope has to remain the same the whole time, okay, in order for it to be linear. So this one would be non-linear. And then if they give you the equations, like down here, as soon as you see an exponent, if you see an exponent in the equation, it is non-linear. So whenever you see an exponent, it's non-linear. And if there are no exponents, and you can kind of put them in the form of y equals mx plus b. For example, if I were to subtract x here, this would turn into y equals 3x plus 5. If you can write it in the form y equals mx plus b, then it is linear. So this one would be linear. Even if you don't know how to manipulate the equation and write it in that form, as long as there are no exponents and then the x and the y are not in the denominator of the fraction, then it's going to be linear. Okay, hope that helped.